So here's another no calculator section. It's written in factored form already. And if you feel like you don't have enough room, just get a piece of scratch paper and write it out, okay? So I'll do standard form then. So 2x, x plus 3 squared. X plus 3 squared means x plus 3 times x plus 3, which is x squared plus 6x plus 9. But then I multiply that by 2x. 2x cubed plus 12x squared plus 18x. Sorry about that. So now in standard form, y equals 2x cubed plus 12x squared plus 18x. Okay? All right, I don't have a calculator to check, so I'm not going to use a calculator. I will let you use the non-fancy calculators. So let me go grab that really quick in case I need it. Okay, so I can use this one. I just can't use a graphing calculator. All right, x-intercepts. Well, the x-intercepts affect me in factored form. So that's 0, 0. And negative 3 is 0 with a multiplicity 2. Yes, you need to write that. You could write it to bounce. That's fine. Zeros and roots are 0 and negative 3. Bounce. You don't need to write it 2 times. You write it here. Don't write it there. Great. You write it here. Don't write it there. Great. You write bounce here and multiplicity 2 here. Great. Whatever you want. Okay. Y-intercept is what's in standard form. Well, if my x is 0, my y is 0. And if you look, there's nothing right there. That's why I have no y-intercept. Okay. Let's back that here. As x approaches negative infinity, f x approaches. As x approaches positive infinity, f of x approaches. All right, quick graph. I know it's not necessarily quick. So 0, negative 3, that's going to be my bounce. It's x cubed reminds me of a line. A line starts from the bottom, 1, 2, 3. So it's going to look something like that, okay? So what I need to make sure of is that I know that that is my bounce, okay? So this is a real value because that's my bounce, negative 3, 0. And this is positive infinity, positive infinity. This is negative infinity, because when it's on the left, it's down, and when it's on the right, it's up. And this one I'll just make up. I don't know, negative 2, who cares? Negative 1, negative 2, whatever you want. Just don't make it negative 3 or negative 7. And then I'll just say, I don't know, negative 5, because I feel like it. Remember, whatever you do, just stay consistent. So there's actually no max or no min. So there's no max because it's at positive infinity. And there's no min because it's at negative infinity. But technically, there's a relative max. My relative max is negative 3, 0. My relative min is negative 2, negative 5. My domain is all real numbers, negative infinity to positive infinity. My range, everything up, everything down, all real numbers. The intervals where it's increasing and decreasing. So from negative infinity to negative 3, it's going up. From negative 3 to negative 2, it's going down. And from negative 2 to positive infinity, it's going back up. Negative 2 to positive infinity, up. All right, end behavior. My end behavior is what's happening at the ends. So on the negative side, it's negative infinity. And on the positive side, it's positive infinity. That one went a lot quicker. All right, last one. So they want the answer in factored form and standard form. Standard form is bonus. I'll take it. Assume this goes forever. So that means all real numbers. Negative infinity to positive infinity. Range. All real numbers. Negative infinity to positive infinity. This is actually a graph that's on here. I can see the lines. So this looks like, I don't know. Well, I guess it's fine. We'll just say 1. I'm okay with it. Let's go 1, negative 3. As long as you label it, actually, that's good enough for me. So that's 1, negative 3, which means this would have to be 0, negative 2. Just stay consistent. Positive infinity, negative infinity, comma, negative infinity. And then let's say that's 1, 2, 3, 4. Negative 4, 3. Just stay consistent. okay? So on the test, factored form will be whole numbers, okay? So let's say that's 2 comma 0. So we'll make that one of the zeros. I don't care, all right? It'll be a whole number. Just make it a whole number. Negative 1 comma 0, that's another 0. And then let's make this negative 5 comma 0. So now that I have all of the zeros, it says write a function. So let's go f of x. If I have 3 zeros, the opposite of negative 5, positive 5. The opposite of negative 1, positive 1. The opposite of positive 2, negative 2. Okay? The relative max, since it says relative, I don't need to state that there is no max. I'll just state that as negative 4, 3. The relative min, I'll state that as 1, negative 3. Intervals increasing and decreasing, negative infinity to negative 4, increasing. Negative 4 to positive 1, decreasing. And 1 to positive infinity, increasing. Okay. All right, so I knew that felt a little bit too like no problem. So there's a mistake, and the mistake is that I didn't account for this y-intercept. If you looked here, if this is your y-intercept and I plugged in 0 here, I wouldn't get negative 2. Let me tell you what I mean. So I'm going to plug negative 2 in for y equals a, plug in 0, 0 plus 1, 0 minus 2. So that's 5 times 1 times negative 2. A equals negative 2. That's negative 10a equals negative 2. So a equals 1/5. So what I need to make sure that I do is that I include that 1/5 in here. So it should be f of x equals, make that a little bit bigger, 1/5 x plus 5, x plus 1, x minus 2. All right, I get bonus for standard form, so let me do that. I would multiply these two first, which would be x squared plus 6x plus 5. It doesn't matter what you do, whatever you want. Then times x minus 2, do my box, dot, dot, dot. I end up getting x cubed. I'll just show the work. So x cubed, 6x squared, 5x, negative 2x squared, negative 12x, negative 10. Diagonals are the same. So I get x cubed plus 4x squared minus 7x minus 10. But then I have that 1/5 on the outside. So I multiply that by 1/5. This is what's going to give you bonus, so it's not a big deal. F of x equals 1/5 x cubed plus 4/5 x squared minus 7/5 x minus 2. If you're not sure, use your calculator. So this would be my bonus in standard form. So that's it. And that, it's not like that's it, that's your test, but I'm done with that page.